Hi, good afternoon. What I want to show you today, first of all, is this is what's connected to the projector, not this. That's probably the main point of this presentation. So this is a Raspberry Pi running Java with JavaFX, and we're booting up now, and my presentation is on this device. And everything on here is a JavaFX presentation. Using full hardware acceleration. So this will come up in a minute. Have to wait for the application to start up. So this isn't something we've released yet. We released a few weeks ago a hardware accelerated JavaFX port to the Beagle board as a developer preview. And this is a preview of the upcoming preview on the Raspberry Pi. Okay, and we're running now. I forgot to switch off the cursor for this one, so we're going to have the cursor around the whole time. Okay, so about me, I'm Daniel Blaukopf. I'm the architect at Oracle who's responsible for making sure that JavaFX runs on small devices like this one. And I have my background in Java for graphical devices goes back a while. I used to port JavaFX, not JavaFX, embedded Java to platforms with graphical user interfaces. So a fair bit of my code made it into a Cisco voice over IP phone and the Kindle Touch, which they don't really hide that they run Java, but they don't advertise it either. But that's all Java with a subset of Java SE in there. And I have other interests as well. I'm a big fan of Lambda. I think it's a great thing that's about 15 years overdue. So I'm really pleased we're getting that in 8 real soon now. And I have a bee in my bonnet about optimization and a lot of opinions about how it should be done. One thing I want to say here, as I hope we go on to the next slide. Okay. Click again, just in case I forgot it. Unfortunately, some of the things in this presentation are a little bit slow. I'm not going to deceive you about the performance of all this. We are, after all, running on a really small embedded platform. The important thing about this bit is I am talking about things that Oracle would like to release in the future, so this isn't a strong commitment to do so, but things we would definitely like to do and to make available as soon as possible. So what you're looking at is, again, JavaFX running on this. Everything is 100% Java, JavaFX. And it's a fairly low-powered platform. In case anyone's missed and hasn't been looking at the embedded Linux market for the last few months, it's a $35 device, very popular now, especially among hobbyists. Fairly weak CPU, surprisingly powerful GPU, which makes it a great platform for accelerated JavaFX. And this is running on the hard float version with a hard float Java VM from Oracle and hard float JavaFX. One of the problems of presenting on this thing is that I can't actually see what I'm looking at. Okay, so what you're getting here is basically the full API of JavaFX with a few exceptions. So all of the core APIs with the animation and the CSS and the scene graph, there are a few things that are not there. Anything that has a dependency of AWT is not included. Although we can run AWT on this device. You can run Swing on the JavaFX just out of the box without any problem. I'm not running on a VM with it at the moment. I'm running on a very slimmed down VM. It's only about 11 megabytes in size with the core libraries, and we're running JavaFX on top of that. Excuse me. So you don't get integration with Swing. You don't get the 2D rendering pipeline. Excuse me. You don't get WebView either, We're not putting it on this device at the moment, although we would like to do so in the future, and internally we have a proof of concept showing that we can. You do get some additional stuff that's just done for embedded. We want this to work on devices. Excuse me. We want this to work also on devices that don't have a keyboard attached. So we have a virtual keyboard input, and you can see this. There are kiosks that just appeared outside with a scheduler application. These allow you to enter your ID and email with a virtual keyboard. And there are some changes made to the controls to help them to work with small devices, with small screens and with touch input. So the class of devices we're looking at, devices down to the level of the Raspberry Pi and a little bit weaker. In fact, initially we were only planning on targeting ARM v7, because that's the vast majority of ARM devices of this class that are out there today. But then the Raspberry Pi came along, and it was such a cool device that we downgraded our minimum to ARM v6 to be able to support that too. And so what we've got here, we've got a Panda board up on the top right. That's what the kiosks are running outside. And the Beagle board, that's what our FX preview is running on. And then the Raspberry Pi, which is what's powering the these large screens that are outside each of these rooms, where you have the scrolling banners with the session schedule on. So if you look closely, you can see those are running on a Raspberry Pi. But what's not clear is that they're running completely in Java and completely in JavaFX. So the kind of device that we're looking at putting this on commercially, apart from its obvious interest as a hobbyist device, is things like home automation. For example, heating or air conditioning control. The more advanced models of fridges that have their user interfaces and alarm systems, and other more business-oriented devices like multifunction printers, which will typically have a display several inches across. Vending machines is another possibility. Healthcare is very interesting. We're looking at the moment. Healthcare devices can mean just about anything in terms of hardware capabilities. It could be from as small as a handheld blood glucose monitor, which will just show maybe a few numbers and maybe a graph in more advanced versions, to the computer attached to an MRI at the high end. And kiosks, obviously, which you can see in the hallway outside. This is an example of our concept of what a printer application might look like. We have this running on embedded devices. I don't have it to show you today, but these are screen captures taken from this application running on a Beagle board. This is the scheduled application. Unfortunately, the kiosks didn't make it until this morning, but there are a couple of them outside now. There's one just outside this room and another one across the hallway. So this lets you log in and see your personal schedule for the conference. Again, everything in JavaFX. The whole application was developed on a Mac and then ran pretty much as is on the device. We had to do a few optimizations, both on the JavaFX stack itself and in the application to get it to run well, but in the end, we're very happy with the results. So the preview release, we released a few weeks ago, right at the end of September, and we provided a binary which will run on the BeagleBoard XM. This is a bit of an old device these days, so we want to look at updating this to run on more modern devices like the Raspberry Pi, and we have the Panda board as well. So this is running on Angstrom Linux. Unfortunately, it's a little difficult to configure. This is partly because the BeagleBoard is an older device, so we wanted to make sure that we could provide touchscreen support with this distribution. And most Linux distributions for the BeagleBoard are a little bit older and don't have the support in the Linux kernel for touchscreens. So in the end, we went for this Angstrom Linux. The big downside of Angstrom is that they don't really have a binary distribution. The correct way to build Angstrom is to build it yourself from source. So instead of providing a binary of Angstrom, we provide instructions to how to build it from source. It's a little difficult to follow, but if you follow the instructions, it does work, and a few people have managed to get that up and running. So that's already available for download. We're planning on updating it very soon. Again, not just for additional devices, but also with bug fixes and regular updates. This is taken from the same code base as the desktop JavaFX. So in addition to support for other devices, we'll have all the bug fixes and feature improvements that have gone into the desktop stack in the previous weeks. Okay, this is one of the slower demos. As I said, I'm not going to deceive you about the performance of this thing. This is a stock ticker. It's taken straight from the ensemble sample from the desktop. It's a straight copy and paste into this application. But it shows you that you have the full charts API here. We have another demo here that performs rather more impressively. No, I have a bug in my application. It's not even doing the animation. I'm going to try that again. Okay, that's what it's supposed to look like. So this is just an animated pie chart where essentially the data is being updated randomly every so often, I think once every frame. And it's a very simple application using the Charts API. Again, lifted as is straight from Ensemble and running on this humble Raspberry Pi. So one thing that's interesting here is what exactly is different about doing this on embedded and the desktop. Essentially, the platforms we're looking at are straight embedded Linux platforms. And a lot of the code, I wrote here 99%, but it's probably more, is absolutely identical on the desktop and embedded. But there are a few places where it has to be different. So one of the differences is that we want to run without X11. You can run X11 on this device, of course, and this has been shown before, running JavaFX on X11, albeit with software rendering. But we don't see that as ideal for embedded devices. There are very few embedded devices deployed out there that we know of where people are choosing to run X11. It's just heavyweight and doesn't give you that much. So we want to run directly on the frame buffer of the device. Most of these devices provide a way to do that. Unfortunately, this is kind of a gap in the EGL specification. The EGL being similar to GLX on the desktop, it defines how you access the frame buffer and render to it using hardware acceleration. There's no real standard for how to do that directly to the frame buffer. So there's a kind of vague definition which isn't actually implemented as is on many of the devices. So there is one way to do this on the BeagleBoard OMAP 3 platform, another way to do it on the Raspberry Pi, another way to do it on the Samsung Oregon platform, a fourth way to do it on Freescale's IMX6 platform, and probably once we start looking at additional platforms, we'll find there are other ways to do it. So we're trying hard to have a common binary that can work on multiple different platforms, but it does mean that every platform we look at is essentially a new port, even if that port is an extension of our existing binary. So it's not the case that we can just take everything, recompile it, and expect it to work. And there are other differences as well. There can also be differences in how input devices are dealt with, and all kinds of other quirks in this device. For example, the Raspberry Pi has a very interesting kind of feature on it. So this was shown at Java 1, and unfortunately, during a keynote at Java 1, this had a little interesting event in which JavaFX essentially crashed. It took us a while to find out why that was. We finally found the answer. It's because with the Raspberry Pi, if you're drawing a lot of power at one time, for example, if both the CPU and the GPU are working hard, then in order to prevent a sudden loss of power to either the CPU or the GPU, then this device will, very cleverly admit, drop power to the Ethernet and USB ports. And we had a bug in our code, which we weren't aware of, we're aware of now, where we couldn't handle that case where we try and read from a USB input device and Linux tells us that our USB port has vanished. It's not an unrecoverable situation, but unfortunately we weren't anticipating it, and our code was anticipating it, and our code wasn't able to recover from it, and we crashed, and I've no idea what just happened now. Okay, I tweaked the power, and we just rebooted. That's okay, I'll just keep talking. At least this will prove to any latecomers that we are in fact running everything here on a Raspberry Pi. So I was talking about quirks of the device. So another thing is the OpenGL support. Different devices support different subsets of the OpenGL extensions and also different EGL extensions. Not only that, but even when they claim a certain level of support, we can't necessarily believe them. So the Raspberry Pi drivers, for example, have either a lack of support or a different way of interpreting how you do for loops inside the GL shader language. And that's something that maybe we can resolve at a driver level. At the moment, we've worked around inside our code. I'm going to try to fast forward through a few of these slides. It may take a while because some of these slides take a certain amount of warm-up in order to get through them. So essentially every device we look at is a new port. We're trying to get good coverage. It's going to take a while before we can come up with something that we can confidently say will run on a large proportion of devices out there. So at the moment we're focusing on a few specific devices. So another thing here is the balance of CPU and GPU power on the devices. So obviously the CPUs are lower powered than on the desktop. That's a no-brainer. If you look at an ARM device and compare it to an Atom device at a similar frequency, you can generally expect to get about half the horsepower out of the ARM device. So what you end up with is the Raspberry Pi has maybe a tenth the CPU processing power of a typical laptop. The GPU is another story altogether, however. Many of these embedded devices have a single, their GPUs will support a single shader. On the desktop, you can have hundreds of shaders supported. So you've already got an order of magnitude difference in the GPU power on top of the order of magnitude difference in the CPU power. Nonetheless, we do find that on most of these devices, running in hardware accelerated mode does significantly increase performance compared with running on the CPU, but the balance is different on different devices. So on the BeagleBoard XM, we find that generally hardware accelerated mode is about twice as fast in our benchmarks as software rendering mode. On the Raspberry Pi, it's about 10 times as fast because the CPU is weaker and the GPU is more powerful. Having said that, it's still an embedded device. There are some things which will work well on the desktop which are just sluggish on this device. And that isn't going to change overnight, but we do expect to see a big jump in the power of these GPUs on these devices. And one thing we're already seeing is just that these GPUs are there. It's hard to find an embedded ARM chipset these days which doesn't have a GPU built in. A few years ago, that just wasn't the case. Okay, so the VM we're running on. So traditionally, the Java SE embedded VM has been large. It started at something like 32 megabytes for running with no graphics support. This stack here we're running on this device is about 20 megabytes, including JavaFX, VM, and core libraries, including everything. And this is our most compact Java SE profile. We're also going to be having profiles with more functionality. And there are some things you don't get in this profile. For example, at the moment, you can't run fxml with JavaFX on this configuration because we haven't got the XML libraries. That is something that we're looking at ways to resolve. And we're running on the hardfloat VM, even though it's the Oracle VM. So that's something we're planning on coming out with soon. Okay, the overall goal of all of this is to provide exactly the same experience for developers, both for Java SE embedded, running on these really low-end devices, and on the desktop. So you should be able to, in most cases, just take your code from the desktop and run it on the device, and we've seen again and again that that does work. And even in the cases where you can't do that, all the APIs and all the paradigms are going to be the same. It's just that you need to do some different optimizations for embedded, and in some cases you'll have APIs that are not present. So with that, we have 9 minutes left for questions. Anyone? Yes?
How do you plan to support OSGI?
The question was how do we plan to support OSGI on these devices? So first of all, obviously that's not part of JavaFX. It's related to the VM and core libraries, but I'll try to address it a little bit. You can run OSGI on the embedded Java SE VM. In the future, Jigsaw, Project Jigsaw, modularization of the VM and libraries will obviously be on these configurations as well, and will be modularizing JavaFX. Without going into too much detail, Project Jigsaw and OSGI are complementary technologies. We won't be using OSGI for our modularization, but we will support running OSGI applications on the Java SE embedded VM. Other questions? I can't quite see everyone at the back, so you might have to wave your hand a bit more if you have a question there. Yes?
You said previously that the swing is out of the question here.
So the question was, is swing out of the question on these embedded devices? So it's a good question. So will you? So you asked if we can swing without AWT. Swing, by definition, requires AWT because it builds on top of AWT APIs. So swing isn't going away, but we're not investing in developing new features for it either. So would it be available on these ARM devices? Can't say for sure. At the moment, it is. At the moment, it's still available. You can go and get the Java SE 7 for embedded for ARM devices, and it will include swing. And then you can run this stack on top of that. However, for JavaFX for embedded, even on a VM which has the swing and AWT libraries, we will not be providing the swing and AWT integration. Yes? You asked about GPIO support. So it's definitely something we'd like to do. It's not something that's going to be part of this preview. Although you will be able to, of course, take a third-party library and with JNI run it together with this. And I believe there is already a library like that available for the Raspberry Pi. Yes? Okay, so you asked how big this the static footprint of this is, and whether we're using Jigsaw. Oh. Okay, so how did we build this, and how did we cut down the size? The main thing was we didn't include WebKit. This is one of the considerations not to include WebKit at the moment. Is that you build WebKit for Linux, it's huge. it adds about 18 megabytes to our flash requirements. And once you take that out, everything gets down to a much more manageable size. Now, that's not the only reason why we're not doing a WebKit at the moment, and it's not a blocker to us including WebKit in the future. We can definitely see a use case where someone would be willing to pay the cost of an additional 18 megabytes even on a small device like this. We did start the work with using Jigsaw for packaging this up. We put that on the back burner at the moment, now that Jigsaw is delayed until SE9, but obviously it's on a roadmap and we'll be modularizing all of JavaFX using Jigsaw. This build doesn't have the media support in yet. If we did have media support, then in that initial, one of those slides at the beginning with the background, where we were scrolling in the Oracle standard legal disclaimer, then I would have played the Star Wars theme tune. Does that answer your question? Okay. Yes? So you asked if we would like to support Wayland in the future. Yes, I think so. With lower priority than running directly on the frame buffer. But Wayland definitely looks more reasonable for small devices than X11 does. Much more feasible. I don't think Wayland is quite ready yet, but yes, it's on our radar. Other questions? Yes.
Maybe tell a bit more about the memory which is on this device and performance, because you can set memory for CPU and GPU.
So you asked about how much memory is on this Pi that I'm showing now, and what the split is between the CPU and the GPU. So this is the Raspberry Pi Model B, which if I remember correctly, it's the 256 megabyte one. The Model C is upgraded to 512 megabytes. We are using a 50-50 split on this between the CPU and the GPU. That's what we generally find is useful for JavaFX applications that use a lot of images and textures. Any other questions?
Did you try it with 500 megabyte twice? Was it better than this one?
So you asked if we tried with 512 megabytes at once. We haven't got any Raspberry Pi Model Cs in-house yet, so we haven't been able to make that experiment. You have one?
Yeah.
We could try that. I think we'll find performance is identical. But yeah, it would be interesting to see if there are any applications that we cannot run on this device that we can on the Model C. Anyone else? Okay, thank you very much.